Hello and thank you for downloading our video on secondary ports and calculations. My name's Noel, I'm the principal at Get Lost Powerboat Training, and you can come to us for any powerboat training or RYA theory courses that you need to do. Anyway, I know you want to get straight into it, so let's take a look at our template. Here's our template then, and in the top left corner we have a table where we can enter the information as we discover it. So the first line, we enter standard port information that we get directly out the almanac, and then what our calculated differences are, the answers for the secondary ports, and if necessary we can add an hour to the times because we will be working in UT, Universal Time. The other three parts of the template are the crocodile teeth or the triangles, and this is where we're going to work out the answers that we need for the secondary ports. Here's our standard port information then from the almanac. This is the first bit of information we have, and we're looking at the times of 11:21 low water 1.8 metres and 18:19 high water 3.9 metres. So we're going to enter those in that top row of our table like this. You'll notice that I've also entered 2.1 metres in the range box at the end. The range, if you remember, is the difference between high water and low water heights. So 3.9 metres minus 1.8 metres gives me a range of 2.1 metres, and that's important when we're deciding whether we're on a spring tide or a neap tide. If you think back to our tidal curve then, we need three pieces of information in order to be able to fill it out. We need a high water height in metre for the top scale, a low water height in metres for the bottom scale, and a high water time for the boxes at the bottom of the curve. So on my template then, I'm going to label my three triangles: high water time, high water height, and low water height. If I was dealing with a curve that was based on low water, the curve would be upside down, so curving from top to bottom and back up again instead of starting at the bottom to the top and back down again. So instead of high water times and heights, I would need to find out low water times and heights. So it's important to always check the curve first to make sure you're not wasting your time. Starting with our high water time triangle then, if we refer back to our secondary port information table, we can see that if high water at the standard port was midnight or midday, it would be 30 minutes earlier at standstill point. Or if high water at the standard port was 6 in the morning or 6 in the evening, it would be 10 minutes earlier at the standard port. Our time at the standard port is 18:19, which falls between 1800 and midnight if you were to draw the scale of time out in a linear fashion. So back to my template then, I've entered that time scale from 6 o'clock in the evening to midnight on my triangle, and I've started with 6 at the bottom and gone up to midnight. It really doesn't matter which way round you put this. On the bottom scale of the triangle, we need to enter the differences from minus 10 minutes to minus 30 minutes, and it's important to get these the correct way round so that the minus 10 minutes starts at 1800 end of the triangle and the minus 30 minutes goes up to the midnight end of the triangle. If you notice as well, my scale along the bottom of the triangle is different to the way I've laid out the scale on the top of the triangle. That's absolutely fine. So long as the bottom scale is even and the top scale is even, it works perfectly. Just got to make sure they're even. The final part of creating these triangles then is to connect the ends of the scales. So I've drawn a line from the midnight to the minus 30 minutes, and that completes our triangle shape. In order to find our time difference then, now that we've completed our triangle, we have to take a parallel line of this line and transpose it down the time scale to the time of our standard port. Reading off the new parallel line then, we can see that at roughly 18:19 at the standard port, we would have a difference of about minus 12 minutes at the secondary port. So we're going to enter that minus 12 in the calculated differences box on our table, and then we can make the calculation and give ourselves the answer for the time of high water at the secondary port. Now that we've calculated our time at the secondary port, the next thing to do is the next triangle, which is to work out the high water height. And if we refer back to our secondary port and standard port information table, we can see that if high water at the standard port was 4.7 metres, we'd have a difference of 0.7 at the secondary port, or 4 metres. And if high water was 3.8 metres, we would have a half metre difference at the secondary port, or 3.3 metres. We're on 3.9 metres, which doesn't match exactly either 4.7 or 3.8, so we're going to have to fill out the triangle. Back to our template then. I'm entering the scale of 4.7 metres to 3.8 metres along the top part of the triangle. And if you notice, my template isn't long enough to go all the way to 3.8 metres. So what I'm going to do is take my pen, extend my scale by an appropriate length and fill in the 3.8 metre value. On the bottom scale of the triangle then, I need to enter minus 0.7 to minus 0.5, and just like the first triangle, I'm using a scale that works out better for my eye. Then I'm going to follow the same steps. As with any triangle, we connect the ends, so I'm drawing a line from 3.8 to minus 0.5 to complete my triangle shape. Then I take a parallel line down to 3.9 metres because that's what's happening at the standard port, and I can see that that line is as close as possible to minus 0.5. Then I enter minus 0.5 in my table at the top left. 3.9 minus 0.5 gives me a high water height at the secondary port of 3.4 metres. Now that we have that high water height, we still need our low water height. And referring to our standard port secondary port information table, we can see that a low water height of 1.9 would be minus 0.3 metres and a low water height of 0.8 would be minus 0.3 metres. So what that table is telling us is regardless of the low water height, we'll always have 30 centimetres less at standsaw point. Back to our template then, and there's no need to fill out the triangle because it's always 30 centimetres less at the secondary port, so we can just fill out our table in the top left. 1.8 metres minus 0.3 metres gives us a low water height of 1.5 metres. And that's it. We're working in UT, so we don't need to add an hour. So I have 3 bits of information now for my tidal curve. I have a time of high water for the boxes at the bottom. I have a height of 3.4 metres for the scale at the top. And I have a height of 1.5 metres for the scale at the bottom. And I can now fill out the tidal curve and use it as normal for my secondary port. There you go then. Hopefully now that's broken down secondary ports for you in a logical fashion and given you a tool that you can come back and refer to again and again along with the article on our website. If you liked what you saw, please do us a favour. Do like our Facebook page, which can be found at Facebook, getlostpowerboattraining.com, and also like our Instagram and YouTube channels. Subscribe to that, and that's under getlostsailing.com. Hopefully, if you do that, you'll be able to enjoy a lot more information. Maybe join our Facebook group if you come and train with us, and we'll see you out on the water soon.